Okay, let's look at an example. So if the instruction was to integrate the integral of x times 1 minus x squared all to the fourth dx, with the instruction using the substitution u equals 1 minus x squared, then we're going to use it. So you can probably see this 1 minus x squared is what's in this bracket. So it's obvious that that will be replaced with a u, and what would that look like? Not that you would write this, but it would look like x times u to the fourth dx. Integrating x and a u to the fourth with respect to x, that's a problem, because we need to be integrating u with respect to u. So it goes on to say that leaves us with two problems, the x and the dx, obviously, and they need to get replaced. Now, what you'll see often is, if you watched the first video, we can get expressions for x and dx. Sometimes that just falls out of other little tricky techniques. Okay, so that becomes the problem. We've got to find something to put instead of x and dx, and that's what we have to work at before we can even set our integral up in terms of u. So by far the majority of the work is in getting the integral from in terms of x to in terms of totally all u. Okay, one method would be, and you might see that other people do it differently, and if you prefer that, then that's fine, go with that. But I think this to me is pretty straightforward. Since we were given that u is equal to 1 minus x squared, if we found in this case du dx, we differentiate u with respect to x. We can do that. Du dx, you know, would be negative 2x. Now, du dx can be treated just like a fraction. We could separate them out. So what are some of the things we could write? We could write that du would be this minus 2x times dx, multiply both sides by dx. Now, that's getting pretty nice in terms of what we could see, back here we had as a problem. We had an x and a dx, and now we can see that we've got an x times dx. If we were to divide both sides by negative 2, then that negative 2 would go and introduce a negative 2 here, divide by. So we are creating an expression for x dx, and all of x dx is in fact negative a half, just taking that negative 2 out, making it a fraction, times du. Why do we want to get x dx? It needs to be replaced. We could see that back here. It needed to be replaced, x and dx. So that's then what we do. So we can now write our integration as, well, all I've done is I've taken the x from the front and I've put it there. That is actually not necessary, but here we're doing the replacement for u. The 1 minus x squared was u, so it's u still to the fourth, and it's minus a half times du. Now, that is really nice. That's asking you to integrate in terms of u to the fourth, and we've got this constant. Remember, using the rule where if you've got a constant times a function, then you can take your constant out. Well, we're going to do exactly that. Our constant is negative a half. We're going to take it out. Our variable is u, not x's, but that doesn't matter. It's u, and we're integrating with respect to u. That's a nice simple integration. Add 1 to the power, divide by the new power, and keep your -1/2 going. Add your constant, and you've got just combining those two fractions, negative u to the 5th on 10. Now, we don't leave it like that because we were asked to integrate it with respect to x. So we simply put our expression for u in terms of x back into there. So it's -1/10. Remember, u was 1 minus x squared, all to the 5th plus a constant. Done. Now, if you need to rewind that video, go back over that, then do that. And maybe you could actually have a go at this next example before you see my solution written up here. So there's a little bit of work we need to do, and you might also know that I've called it type 1, and that's because this is when we're told to substitute u in terms of x, and we usually see this as part of the function. You can see it's down there in a bracket. Now, keep in mind this is one type. There's a different type of substitution that we can be given, but I've separated that into type 2, and we'll talk about that separately. So we'll do a couple of these where we're told what u has to be. So we know that from this, du dx would be equal to, and why am I thinking that? Because I want to remove that dx and I want to get du into it because I'm going to have a function in terms of u. What would du dx be? Just simply differentiating this, it's 2x. Now, you can see from that we could write du is 2x times dx, and actually we wouldn't go anywhere from that because look at what is happening here. We've got a 2x and we've got a dx, and they're being multiplied. So anywhere we see 2x times dx, we can totally replace it with du. Now that's really nice. I think we're ready to get started. So this would become the integral, and if I write it as 1 over, I'll just do it all really long-handed, and you wouldn't necessarily do this. So that's just separating it into a fraction 1 over x squared all squared. Separate the 2x from out of that fraction, and it still remains a numerator, and multiply by dx. Why? Because this we've created a replacement for. 2x times dx could actually be called du. Now, they won't all be this simple. This one is really nice and simple. And what have I got happening here? I've got 1 over, 1 plus x squared is u, 1 over u squared. How do we integrate that? Well, we're going to bring we don't integrate a fraction, and we could write that as u to the -2 with respect to u. How do we, is it in a format that we can integrate? Yes. Add 1 to the index, add 1, divide by the new index, plus a constant. So we've got -1 on u plus a constant, and we need to return that to its x format, so it's -1 on 1 plus x squared plus some constant. Let's have a look at the next example. We're integrating 3 over the square root of 3x minus 5 dx, but using the substitution that u is equal to 3x minus 5. So we can see that everything under the square root would be replaced with a u. Now, that's all good, but we've got a dx problem. So if we work out du dx, then we see that du dx, differentiating that with respect to x, is simply 3. That means then that du is equal to 3 times dx. And again, really nice, convenient result there, because that's exactly what we've got here. What do we know that that could be replaced with? It could be simply replaced with du. So we know this is going to be equal to 1 over the square root of u times du. How would we write that? We know that that's the integral. That's not in a format that we can integrate, but square root of u is u to the half, and when it's in the denominator it's a negative a half. So when we bring it to the top, negative a half times du. Nice easy integration with respect to u. Add 1 to the index. Add 1 to the index. So that's a half. And divide by the new index. Dividing by a half is the same as multiplying by 2 plus the constant. Putting this back in terms of x, the x pronumeral, u is simply 3x minus 5. So we keep that, replace the u, and we've got the constant. Actually, rather than doing introducing type 2 now, because it won't be required, type 2 doesn't come in until the exercise 6D, I'm going to leave that. The other thing that does come into 6C is the applications of the derivative, which you know is getting things like the gradient or the equation of a tangent, those sorts of things. Or we're integrating, getting the original function, or given the gradient function, getting the original function, or finding area, all those sorts of things. So some of those sorts of questions will come up in 6C. So in a separate video, I'll actually do this application, and you should be right then to do all of those questions out of 6C.